Hi everyone, I am Sai Krishna Avala from Software Engineering and Testing Lab at IIT Gandhinagar, India. In this demonstration, I'll be talking about a tool named MineCPP. MineCPP is a tool to mine GitHub repositories and obtain a dataset containing a list of bug fix pairs and related information. MineCPP is also known as Minecraft++ as it is an extension to our previous work, Minecraft. So here is the flowchart of MineCPP and it is built on top of Minecraft. As you can see that MineCPP takes GitHub URL as input and produces a data set of bug fix pairs as output. Along with the Minecraft's output, it added an additional features like similarity scores, cyclomatic complexity, coding effort, constructs, and test file. So coding effort is a novel term introduced here and will be explained later in the tools walkthrough. Now let's get started with the installation. Before installation, make sure Python and C++14 is installed as MineCPP is based on Python and the parser it uses needs C++. So the installation can be done with a simple pip command, that is pip install MineCPP. This will take a good amount of time, like around 5 minutes. I guess the installation is done. In order to check whether the tool is installed properly or not, you can use the command MineCPP. Yeah, now you can see that it gives the tool's details. So MineCPP has like 3 arguments. One is h, version, and URL. So the h argument MineCPP h, yeah, it displays the tool's usage and the output schema of the dataset. As you can see that there are 14 columns in the dataset, and these are before bug fix. It represents the code snippet containing a bug. After bug fix, it represents the code snippet after the bug is fixed. Location, it represents the line numbers, and it has 2 sub fields. One is after field. This represents the line number where the bug is fixed, and before field, which represents the line number where the bug was found. Bug type, it represents the type of bug obtained from LLM using gitdiff between the fixed commit and the buggy commit. Commit message, it is the author's message for this particular commit. File path, so it represents the path of file in which the change is present or the bug is fixed. Test file, it denotes whether the test case is present for a bug fix. Here 1 represents that the test case is present and 0 represents it is absent. Coding effort, as I told you, it is a novel term introduced in this tool. It represents the effort an author makes before a bug is introduced in the source code, and it is obtained from the abstract syntax tree of the source code. Constructs, it represents the type of constructs in which the bug is occurred. Lizard features buggy and lizard features fixed, they denote the cyclomatic complexity of the buggy and bug fix file. Blue, crystal blue, bird score represents the 3 different similarity scores between the buggy and fixed codes, and these scores lies between range 0 to 1, where 1 indicates the codes are similar and 0 indicates they are dissimilar. In this demonstration, I'll be analyzing the GitHub repo named geocoder, and it can be done with the simple command MineCPP -u and the GitHub URL. So the processing will take a good amount of time, like few minutes to few hours. Yeah, it started collecting the data. As we can see, the total number of commits is 1251. Now it's the phase of processing SZZ. It is the process which actually gives the buggy files. I guess the process got started. It's processing the commits. So it will be processing each and every commit, like there are around 1251 commits. So these will be processed since it has to collect many features like before bug fix, after bug fix, location. So it's gonna take a good amount of time. Now we can see that it's only 0%, so it will take some time. Once the processes get completed, it opens a web browser. It has like 3 options: dataset visualization, dataset quantitative analysis, and exit. This is the GUI provided by MineCPP. When you go through dataset visualization, you could see there are 14 columns as mentioned in the usage, and there it also provides an interactive dataset, because when you click on this before bug fix, you directly go to that particular repository and the file. So this can be used for detailed analysis of the bug information. And we also provide a clickable header so that if you click on it, it gives the definition of the particular column. There is also a more option which can be used to unroll the next set of rows. At a particular amount of time, at any time, there are only 10 rows displayed in a web page. When you go to the quantitative analysis, it provides you a field to enter the number of rows. Depending on the number of rows, a plot is generated. So here we can see that the plot is generated for the first 100 bug fix pairs. And if I go beyond like 500, I'll get the plot for those 500 pairs. As the geocoded dataset is small, it has like 800 rows. I can just give a number about that and it will give me those 800 sets of bug fix pairs. This is the plot for coding effort versus bug fix pairs, and this is the plot for similarity scores versus bug fix pairs. These plots can be used for analysis of the bug fix pairs throughout the repository's timeline. Now we also have an exit button. When pressed, you have an option of either going back again or just killing the processes. This will kill the process. Yeah. Thank you. The tool is available at our GitHub repo and can be accessed through this QR.